Hello, I welcome you all to our YouTube channel, and today we are discussing the different type of mechanical testing, and we will give a brief introduction on these mechanical tests and their corresponding ASTM standards. So these are the different kind of mechanical tests. For example, we have tensile test, we have this tensile test, impact testing, fatigue testing, fracture toughness, compression, the stress rupture and creep testing, hardness and shear testing. And now we will give a brief introduction on these individual mechanical tests. So first thing, the tensile test. So that in this tensile test, we subject the specimen to a stretching. Like we have a specimen and we will stretch this sample. So this is known as tension. And in tensile testing, we subject a component to tension testing. And from this, we are getting the tensile strength, which is your ultimate, which is the uh, maximum strength we get in the tensile test. And then we have yield strength and elongation of the material. Second thing is compression testing. It is bit similar to the tensile test, but the main difference is the nature of force. Here we have tension force in the tensile testing, but in compression test we have compressive forces. So again we measure the force versus displacement or stress versus strain response of the material during this test. And third one is hardness testing. Hardness is a surface property, and in this we measure the uh, ability of the material or ability of the surface to resist the indentation or scratching. And next one is fatigue testing. The fatigue testing is similar to what we did in the tensile or compression testing, but the main difference is in the tensile testing we have the force was applied in a quasi static manner, like it is increasing steadily, but here the force is varying with time, like periodic motion we use in the fatigue testing. So the fatigue testing we measure the ability of the material to resist the periodic loading. Next one is impact loading. So, like I said in the fatigue for the tension test, the loading is quasi-static or it increases steadily. But in impact testing, what we do is the loading is very sudden, like like in the case of the accident, or you can visualize in terms of a bullet. So when the bullet impacts material, so the impact will be very sudden, like the force we applied will be very sudden, and this type of resistance to this type of loading is calculated in impact testing. Next test is fracture toughness testing. So in fracture toughness, what we do is we made a crack in the specimen, and then we test the ability of the material to withstand load in the present of this crack. And in the previous loading we don't have a crack, we just have a plain specimen, like for tension or the compression test. Next one is creep testing. This is mainly done at higher temperature. So what happens is, at higher temperature, even under the constant load, the material start deforming. So the resistance of a material to deformation at higher temperature is usually evaluated using this creep testing. This type of deformation is usually time dependent. It means like it doesn't happen instantaneously, like it happens over a period of time, like few days, few hours or few days. And the next one is shear testing. So in this is mainly a different kind of force, like in I have explained in the tension or compression. This in shear force, what happens is this type of force happens, like we apply a shear force to a component, and then we test the resistance of a material to a shear force. As similar is torsion testing. In this test we take a cylinder and we apply a torsion loading on this, and we twist the material and check the ability of material to resist this kind of loading. And similarly, the bending test, as the name indicates, we will take a specimen and then we will try to bend it like this. So once we bend the specimen, the ability of the material to resist this bending or the flexural strength of the material, this is called as bending testing. Now we'll talk about few selected mechanical tests and their corresponding ASTM standard. So first one is tensile testing. As I have explained before, this is the behavior of the material in tension. So we stress the material and then we check the response of the material under this tensile test, tension loading. So this is one of the most fundamental mechanical tests, and this is basically one of the main property we need for the mechanical testing. So this is a typical stress strain curve. So here we can see as the strain increases, so as we elongate this material, it will take more load, and first we will it will increase linearly. So up to this point, the yield strength, if we unload the material, it will come back to its original position. But after that, the plastic deformation occurs, and here we can see now in the plastic deformation, the elongation is permanent. Like if it is stressed like this, so it will remain like this. It will not go to its original position like this shape. And finally, when the load crosses this ultimate strength or maximum strength, then what happens is the necking happens. It's the this you can see this section is it forms a neck this shape it forms. So from this curve, we are getting few properties. Like first one is the slope of this initial region, the linear region. From here we get the Young's modulus or modulus of elasticity. The slope of this initial region is called Young's modulus. And up to the point where the material is elastic, that point is called as yield strength. And then the maximum stress we get, this is called as tensile strength or ultimate tensile strength. The region here where in the plastic deformation region where the stress increases, this region is called as strain hardening. And now the final region, this when the necking occurs, in this region the necking occurs, and finally when the materials fail here, this is called as total elongation, and this is a measure of ductility of the material. So here you can see in this figure the things I have explained in previous figure. It is shown in detail here. First we have linear region. Here we have yield strength. Second we have ultimate tensile strength, which is the maximum stress, and finally we have this fracture. So in the first region up to this point, there is another constant we use, that area under this curve, like this area, it is called as resilience. And if I take the total area, like this whole area from this start point up to fracture, this region is, this whole area is called as roughness. Okay, so
mainly focus.
so now we'll come to the ASTM standard for tensile testing in different kind of material. Like for the metallic material, we have this ASTM A8 standards, and for composite material, we have this ASTM D3039 standard. And finally, for the reinforced plastic or unreinforced plastic, we have D638 standard. For most of the application, we uses this metallic materials, and hence we use this ASTM E8 standard. In this ASTM E8 standard, we have different kind of specimen, like we have sub size or standard size specimen. So these the ASTM standard does not have one fixed size, like it has different dimension uh, for the tensile test specimen. The shape of the tensile test specimen is called as dog bone shape. It is somewhat like this. So it is of two types. First one is the rectangular type, and second one is circular. So this ASTM standard defines both type of the specimen, the rectangular cross section and the circular cross section also, and the shape of the specimen is always dog bone shaped. Now the fatigue testing. So the fatigue testing, as I have explained briefly in the introduction section, it is the one second. It is the response of the material in the presence of cyclic loading. So in cyclic loading, the as the name implies, the loading changes with time. So and the most important thing is like we have shown in the tensile test, there is a yield point and there is a ultimate tensile strength point. So what happens during this periodic loading is, the actually the material is supposed to take this maximum load under tensile test, but under fatigue test it will take very less load compared to this. So it is very important to do the fatigue testing to understand the material's behavior under the repeated loading. So now we'll briefly discuss the different term associated with this repeated loading in the fatigue test. So this is a sine wave, and here we are showing the different stress. Like first one is this minimum stress, second one is maximum stress, and then we defined a term called as stress amplitude. So this stress amplitude is sigma max minus sigma min by 2. So here you can see this is the amplitude, and the second term we define is the mean stress. Mean stress is the middle term between this sigma max and sigma min, and it is defined by 1 by 2 sigma max plus sigma min. This is mean stress. And last term we define is the stress ratio, which is defined as sigma min by sigma max. This is so so this the fatigue response of the material depends on all these things. Like first of all, I'll talk about the fatigue strength. So fatigue strength is okay. So fatigue strength is defined as, is sometime also called as the endurance limit, and this strength is defined according in the aluminum alloys. It is generally taken as 10 raised to power 7 cycle. The stress it takes to complete 10 raised to power 7 cycle is called as fatigue strength, and for other alloy I'll discuss later. And other things like this mean stress, this also has a very significant role in the fatigue life. For example, like we can see, if this is 0, then this mean stress is positive, and if the mean stress is positive, then fatigue life will decrease. Like if you have the mean stress as 0, and if you have mean stress of something like plus 100, so the fatigue life will be lower in the 100 megapascal one. And similarly, if the mean stress is negative or the mean stress is compressive, then the fatigue life will be higher. So now we'll discuss more about this curve, which is stress versus number of cycle. This in this curve we can see, as the stress decreases, the number of cycle increases, which is obviously like for lower stress the life of the component will be higher. So here we can see, for this curve is for steel. So for steel like material we get a flat line. So below this is called as endurance limit. So below this stress, the fatigue crack will not grow, or the fatigue loading is not important. Like the component can take infinite number of cycle. But for aluminum alloy we don't have a well defined this endurance limit. Like we don't have a straight line like this. It will go on, the fatigue curve will go on like this. So here we assume that up to like 10 raised to power 7 or 10 raised to power 8 also we take sometime. So this is called as fatigue strength. Here in the aluminum alloys we don't get a well defined endurance limit. Now we'll come to the ASTM standard, and first of all this fatigue loading. So here we can see there are different ASTM standard for this strain control loading and the force control loading. So first this ASTM E606 is for strain control, and the ASTM 466 is for force control. And now I'll talk briefly about what this strain control is. Like we have this curve. So if we, as the name indicates, we control the strain. So strain is this elongation by delta L by L. So we control the elongation, and it is mainly used in low cycle fatigue. And this force control loading is used for high cycle fatigue. And in this one we control the force applied to the specimen. So now we'll come to fracture toughness. As I explained initially, it is the response of the material in the presence of a crack. So we'll apply the load and check the response of the material if the crack is present. So for fracture toughness, we have two type of specimens. First one is called 3-point bend test. In this we have one loading and two supports. These are supports and this is load. And there a crack is applied here. So when we apply the load, it will feel like this. Okay, the second type of component is called as compact tension or CT specimen. So here you can see this specimen geometry. So we apply loading on these two holes, and we use a small pre-crack in this region, and as the load we apply load on this side, this crack will grow in this direction. And the fracture toughness is evaluated using some empirical formula as per the ASTM standard. So these are the different standards for the fracture toughness, and what we commonly used are these two. First one is ASTM E399 standard, and second one is called ASTM E1820. These the formulas required, empirical formula required for evaluating fracture toughness is we obtain from these two for metallic materials. And these are some other uh, the other standard, but we don't generally use these. So now the hardness test. Hardness test is the ability of material to resist the scratching on the surface. It is a surface property, and we use we penetrate the surface using a harder material to check the resistance of the surface for scratching. And these are the different kind of hardness test. First one is called Rockwell. So these are the different kind of hardness testing. In this we applied a force using this indenter, and then it will leave a indent like this, and we'll check the dimension of this indent to get the hardness value. And this different kind of test I'll explain further. So these are the different kind of indenter we use for the hardness test. First one is called Brennan. So in this one we use a steel or tungsten carbide sphere, and we indent the ball in this fashion, and we'll check the dimension of the indent to get the hardness value. Similarly, in Vickers hardness, we used a diamond tip which is in the pyramidal shape, and the angle between the pyramid side is 136 degree. The next one is called Knoop hardness. This is similar to the Vickers hardness. It uses a diamond tip and the pyramidal shape, but here the dimensions are bit flat. It is used where the thickness of the specimen is bit low. And the final one is called Rockwell hardness. So So in this we have two type of indenter. First one is this the diamond cone, and second one is the spherical, the steel spiral, which is similar to the Brenner hardness. Okay, now we have different standard for different kind of hardness testing. So we have this. So we have this E10 for Brenner hardness, E18 for Rockwell hardness, this E92 for Wicker hardness, this E103 for rapid indentation hardness testing, E1110 for metallic material, and E140 is used for the conversion between these different kind of tests like Brenner, Rockwell, Vickers. Now E384 is for micro hardness. Here the indent will be of bit smaller dimension compared to normal hardness. This is next one is E1842, which is for Rockwell hardness. Thank you for watching this video. We have explained in this video about tensile test, fracture toughness test, the hardness test, and the fatigue test. If you have any further queries, you can write in the comment section, and we'll come up with more mechanical testing videos in the future.